MXB106 and we're going to be solving problem 4.
The first step is to integrate the first order non-linear differential equation, which is separable.
To solve this differential equation, firstly we can observe that this is a first order differential equation and is separable. Referring from week 8 lectures, we can write it as dp over dt equals ht times gp. Where ht equals r, we then get gp equals 1 minus p on k times p, which equals 1 on k times kp minus p squared.
Assuming the solution is of the form p equals phi t, we get dp over dt equals phi prime of t. Subbing this back into our differential equation, we get 1 over g phi t times phi prime of t equals h of t. Integrating both sides with respect to t, we get this. From this part, we can note that dp is the same as phi prime of t times dt. Subbing this back into here, our integral is now 1 over gp with respect to p equals the integral of h of t with respect to t.
Now subbing in the values of gp and ht, which gives us this. Now we integrate both sides. The right side gives us rt plus c1. Factoring out k from the left side and dividing it from both sides, we get this.
Now that we have expressed the left-hand side of this in terms of partial fractions from here, giving us this, we can factorize out the 1 over k and put it out here, and then multiply both sides of the equation by k, giving us this. Integrating the left-hand side gives us this, which we can combine with log laws to give us this. Exponentiating both sides and letting c equals c1 minus c2 gives us this, which then gives us this, where a equals e to the c. Our final explicit solution for our differential equation is p over k minus p equals a e to the rt.
Okay, so now we can solve for the values of a, r and k using the given points and the implicit solution p over k take p equals a e to the rt. And we'll be saying that t will be the year since 1990. So this gives us the values here, where t equals 0 equals population 100, t equals 10 is population 130, and t equals 20 equals a population of 160. So now we can form these three equations from these values. So this is where t equals 0 and p equals 100, which gives us equation 1. T equals 10 and p equals 130, which gives us equation 2. And t equals 20 and p equals 160, which gives us equation 3. And all these equations will be used in the next steps.
So now for the following section, we'll be solving for a, r and k. This is solving for k. Using equation 2 of 130 over k minus 130 equals a e to the power of 10r. We square both sides, which gives us this, and using equation 1 and equation 3, we get this, with 100 over k take 100 as a, and 160 over k take 160 as a e to the power of 20r. We then multiply this out and divide it by 100, which gives us this. We then we use cross multiplication for this, and multiply these out to get this. Now we add all the like terms together and bring it to one side, which gives us 9k squared, take 2,340k equaling 0. We divide both sides by 9 and bring the k out. This gives us k equals 0 or k equals 260. And k clearly can't equal 0 from the given differential equation. Therefore, k equals 260, which is our equation 4 now. And now we'll solve for a. Using equation 1, a equals 100 over k take 100. We now sub in k equals 260, which is equation 4. Therefore, a equals 100 over 260 take 100, which equals, through simplification, 5 over 8, which is now our equation 5. So now we'll be solving for r. Using equation 2 of a e to the power of 10r equals 130 over k take 130. Now we're subbing in a equals 5 over 8, which is equation 5, and k equals 260, which is equation 4. And we get this. 5 over 8 e to the power of 10r equals 130 over 260 minus 130. Through simplification we get this. E to the power of 10r equals 8 over 5. Using the log laws, we get 10r equals ln of 8 over 5. Bringing the 10 over the other side, r therefore equals ln of 8 over 5 all over 10, which approximately equals 0.047.
So now we can solve for an explicit solution which directly relates the population with time, and we can do this from the original implicit solution of P over K take P equals A e to the RT. So firstly, we take K and plus K on the top of the fraction, which is essentially adding 0, and this can simplify down to this formula here, which is K on K take P take 1 equals A e to the RT, and through further simplification, we get this formula here, P equals K, take K on A e to the RT plus 1. Now taking K out from both terms gives us the P equals K brackets 1, take 1 on A to the RT plus 1. And by simplifying this further, we get that P will equal K brackets A e to the RT on A e to the power of RT plus 1. And that gives us our explicit solution of the population in terms of time. So now we can sub in the values of A, K and R, which were found previously, into the explicit solution where population was in terms of time. So our equation was P equals K brackets A e to the RT on A e to the power of RT plus 1, and subbing in this value, these A, R and K values gives us this equation here, and then from this we can simplify this down to 260 in brackets 8 over 5 to the power of t over 10 on 8 over 5 to the power of t over 10 plus 8 over 5, and now dividing each side by the top of the fraction here gives us this equation here, which we can then simplify down into our final equation of population in terms of time equals 260 on 1 plus 8 over 5 to the power of 1 take t over 10, and this is the simplest form of the DE when subbing in the values solved for A, R and K and using the values that were provided in the question.
Okay, now that we have the DE in the simplest form, as seen here, we want to solve for the population at 2020, where in this case t is equal to 30. This is because t is equal to 0 at 1990, then 30 years later, 2020, we have t equals 30. We sub in 30 into the equation here, as seen. We then simplify this bracket section here to get negative 2. From this, we can simplify further so that 8 over 5 to the power of negative 2, we will reciprocate and it will become 5 over 8 squared. We then square this to end up with 260 divided by 1 plus 25 over 64. The denominator is simplified to 89 over 64. This double divide is messy, so to simplify this further, we do 260 multiplied by 64 divided by 89. Now we end up with 16,640 divided by 89. Thus, the population in 2020 will be 186.96, roughly. Now, we want the value of t, we want the population as the value of t approaches infinity. To do this, we find the limit of our formula here, where the limit as t approaches infinity of the formula will be 1 minus t over, where the value of t over 10 will be simplified to t, infinity, over 10 will still be a very large number, meaning 1 minus a very large number will be negative infinity. 8 divided by 5 to the power of negative infinity, as we did here, we can reciprocate so that the power is positive, meaning 5 over 8 will be to the power of positive infinity. Since 5 over 8 is less than 1, we have a fraction that when put to the power of infinity will go towards 0. Since it progresses towards 0, we have 1 plus a number that approaches 0 on the denominator. 260 divided by 1 gives us 260, which was our k value. Therefore, the population will go to 260 as t approaches infinity.
In our group, we solved the following differential equation to obtain an explicit formula for p using the initial values. From part 4, we can observe that as t goes to very large values, the population asymptotes towards 260, or our k value. So, examining this formula, we can observe that k is the physical limit, is the hard limit on the population.
To conclude, we firstly solve the differential equation to produce P on K take P equals A e to the power of RT. We then solve for the variables A, R and K to produce our final equation of population in terms of time, which is here. We then found that the population at 2020 was approximately 187, and that as T approaches infinity, the population will also approach 260. Thank you.